So for the 9.3, 9.4, here we are covering for the hypothesis testing when we try to compare two samples average, right? And in this case here, we have the, if you remember, 9.3 is to deal with when those two samples, they are dependent, right? 9.4 is to deal with like two proportion case, right? So very quickly, we can go over those homework questions. Which of the following represents dependent samples? So number one, lifespans of pairs of siblings. Everybody, siblings, they have some relationship, right? I mean, it's coming from the same family. They are dependent. So one is the dependent, right? Number two, lifespans of a randomly selected pair of people, right? Randomly, that's good. That means independent, okay? Number three, lifespans of pairs of mothers and daughters, right? So mothers and daughters. So, I mean, they have this relationship here. They are not random, they are dependent. So in this case here, there's 1 and 3, that's the answer is B. They are dependent samples. Is that clear? Now, continue here. We are trying to study using some booster will increase gasoline mileage or not, right? So random sample of 7 cars was selected. So how do they do this testing? Is the cars was driving, right, for 2 weeks without a booster and 2 weeks with the booster, right? So you see this column here is without a booster. Those the MPG, miles per gallon, 7 numbers here, right? And the corresponding, this column here is the with booster. What's the corresponding MPG? You can see the first car here is a paired, right? This one is 21.2 miles per gallon, 23.8. I mean, looks like it increased, right? 2 point something, right? And then similarly for the second one, and so on, right? How do we solve this question? Determine the mean of the difference, the average of the difference. So in other words, we have to calculate the difference. Is that right? So in other words, we have to write down another column here, which is the difference, right? So if I write down here, that's a difference. Right, difference column. So you are going to use 21.2, right? The difference, X definition here, X1 minus X2, right? 21.2 minus 23.8. So you can create this, right? Is equal to using Punchy calculator to do the calculation. That's for the first one. And similarly for the second one, I think this one is negative 2.6, right? I can write down this, negative 2.6, right? So on, right? For the second one here is about to be negative 0.2, I think. X1 minus 2, right? This one is going to be negative 1.5. Like that. You can do the X1 minus that, right? Correspond, right? So now you have all those numbers, 7 numbers, and then you add them together, divided by 7. That's the average of a difference. That's easy, right? Everybody? So far, so good. Number 3, actually, is the same question. It's the same question, the same information. You see that here? We are using exactly the same information. Now, we want to calculate the standard deviation of a difference. So how do we calculate that? The standard deviation of a difference. So you can go back to the lecture notes, everybody. Now we got these 7 numbers here, right? Out of those 7 numbers, we can calculate the average, which is pretty straightforward, is that right? So adding them together, divided by 7. So like last one here should be negative 1.8. That's the last number here, right? I'm lazy here, okay? So you add those numbers together, divided by 7, you got the average. So how do we calculate this standard deviation? Remember that beautiful formula, right? So we are using like that beautiful formula to do that step-by-step calculation, using that one. So that's to answer second part question, number 3. Number 4 here is the same information we are given, right? Same information here. Now, We are trying to answer what's the critical value we should use. What's the critical value we should use at alpha equal to 5%? Everybody, this is a little bit tricky here, right? Like for this question here, do we have to do this like if this question is showing up on the exam or on the final, right? My question is, do you have to do this calculation here, right? If it's for this question only, we don't have to do any of those calculations. Everybody, as I mentioned previously, right? If you can be lazy, why not? Okay. We are asking this question here as well. Try to find out what's the critical value. Remember, where's the critical value coming from? The critical value is coming from a table, right? Which table we have to use here? Remember, after we calculate the difference, right? We calculate the average of those difference, and then we calculate the sample standard deviation. Based on that sample standard deviation, we know we have to use T formula. In other words, T table. So we are going to open the T table here. Let me, where's my T table? The T table is this beautiful one-page T table here, right? So we are trying to see alpha equal to 5%, right? Alpha equal to 5%. Let's check. Is that one side or two side? Everybody check this statement here, right? Wants to determine if using the booster will increase the gasoline mileage. So that tells us it's one side test. So in other words, we should use the first row, right? Alpha equal to 5%. So that's this first row here, right? This column, 5%. Now, which column we are going to use, which row, right? We are going to cross degree of freedom. Degree of freedom, n minus 1. We have 7 cars, right? 7 minus 1, 6. So 0.05, 7 minus 1, 6, right? So it's 1.943. 1.943. Everybody follow me? Right? 1.943. Now the question here is, I mean, all of them, they are negative, right? I mean, that's good. So if we, why we have a negative here, right? Why? Because if we draw the table here, you will realize this is a T table, symmetric, right? Symmetric T table. When we write down H0 here, if you remember, right? This is a difference, X1 minus X2. So when they say increase, right? Increase means what? Using booster, this number is going to be higher. So in other words, all those numbers here should be higher than this number here overall. They are trying to see if that's the case, right? So they are going to see like the mu1, right, is the difference, right? Mu1 minus mu2, so which is the difference. We are going to use, if I remember, we are using that notation V bar, right? Let me erase that. I don't want to get confused here, right? So the D bar, that's the D bar, right? Is it going to be bigger than 0 or less than 0? Everybody be careful. They say, when they say using the booster, we are increased, means this number is bigger. So X1 minus 2X2 will be actually smaller, less than 0. You see that? So in other words, less than 0 is what? To the left, right? So when we check the critical value, we should get the corresponding negative number instead of positive. Follow me? So that's the reason we are using 1.946 instead of positive. Okay, so let's erase that. Next question here, we have, right. Now we are given this sample of 5 matched pairs. Everybody, whenever you see these keywords, right, matched, that means what? That means it's a dependent, right? It's like the example we learned in class. Before the medication, after medication. With the booster, without the booster, they are matched. So that means we are using the dependent case, right? We have to use the difference, right? Like 23 minus 19, calculate difference. And based on that, to do the calculation, the test statistics. So that is the same example that we mentioned earlier. I'm not going to repeat that. Okay, so it's using the difference, right? So once you got this row here and using that row to do the calculation, you will get the test statistics using the T formula, everybody. So what I can give you some hints here is a T formula. One sample, T formula, okay. Now, let's see. Number 6. In the experiment to determine whether there is a systematic difference between the weights of obtained with 2 different mass balance. Okay, 6 specimens were weighted in grams on each balance. Okay, so we have 2 devices. I mean, that's because some English letters I'm not quite understanding what's their meaning here. But doesn't matter, right? As long as I got the general idea, right? So 2 devices, device A, device B, to measure the same thing, right? I don't know what's that, but doesn't matter. So we have this A, B, they are the same. This case here, number 2, they are a little bit different, right? Okay, so that's the information we are getting. Now, write down the null hypothesis, the alternative hypothesis, everybody, right? H0 always equal, everybody. So based on that information we are given, we cross out B, no way, right? Okay, so now H1 determine what is asking, is that right? So H1 determine there's a systematic difference between the weights, right? Do they say the one is higher than the other or less than the other? They didn't say that. So in other words, we shouldn't use this one, right? I mean, this case here is equal, no way. In H1, we never have the equal case, right? H0 always equal, right? So we cross out B here, we cross out A because less than. Here should be not equal, the answer is D. Number 7, same thing here, right? Same information we are given here, right? Calculate the test statistics. So we are using 2 devices to measure the same thing. So which is a paired, matched case. So you have to calculate the difference using that difference to do the calculation. I'm not going, it's the same as the previous one. Number 8 here. So the football coach at some university wish to determine if there's a change in offensive production between the first half and the second half of his team. Okay, so trying to see that the game number 1, right? First half, second half was the offensive production, right? So that's the information we are given. Now the question here is we have to write down the null hypothesis, the alternative hypothesis, right? In other words, do we have to care about those numbers? No, we don't need to worry about those, everybody. You don't need to jump onto the calculation right away. This one minus that, this one minus that. No, if we can be lazy, why not? Because that's not what we're asking here, right? We're asking null hypothesis always equal. Okay, always equal. We cannot cross out anything yet, right? Alternative here, they are, depending on what's asking, they are trying to determine if there's a change, right? If there's a change, do they say it's higher or lower? No, they didn't say that. I didn't see any. Is the first half is higher or lower? Did they say that? No, they did not say that. Should be non-equal to 0. Follow me, everybody? Right, the other one's not right. A medical researcher is interested in whether parents' left arm or right arm are patients. Left arms or right arms are longer. Wow. 9 patients selected. How many degree of freedom should the researcher use when trying to find the critical value for the t-test, right? So in this case, they are trying to see the difference of left arm, right arm, the difference, right? Degree of freedom, n-1. Remember how many I mean, each patient, they have the left arm, they have the right arm. So the number of degree of freedom here is 9 minus 1, which is 8, right? 8. And if we want to use they specifically mentioned that t-test, right? Let's see, t-test, t-distribution, right? So t-table here, everybody, do they say, is one side or two sides? Let's check, right? So whether this left arm or right arm are longer. Do they specifically, say is the left is longer or the right is longer? They did not say that. It's just by two sides. Everybody, two tails. Two tails by default. There's no alpha specified here. So alpha is 5%, everybody, right? So this row, this column here, what's the degree of freedom? And degree of freedom n minus 1 is, okay. Actually, we don't have to use this table. You don't need to worry about that even, right? Everybody? Remember, what's the question they're asking? Degree of freedom, you see? If I can be lazy, why not? It's what? 9 minus 1, 8. That's it. I don't need to worry about this table, right? Because then when we are worried about this table, we have to worry about is one tail or two tail. What's the alpha? Because they did not mention that here, we assume alpha is 5%, right? For the proportion one, everybody, p hat, right? So you can write down the p hat is equal to x divided by n. That's easy, right? So 34 minus divided by 38, that's the answer. Similarly, if p hat is equal to 6 over 20, and now the formula is given by, let me write down this so you know what I'm talking about. P hat, the formula for those two questions, right, is equal to x over n. So how many out of a total n, right? So I'm not going to, it's very more easy. I'm not going to cover that. Finding the P bar and the Q bar for this case here, remember we have that example, like we are trying to see the drivers from this year and last year, right? 1,000 drivers each, trying to see if there's a significant decrease in terms of the percentage of people doing the texting on the cell phone, right? So we have that formula. Go back to the lecture notes. How do we calculate P bar, Q bar? We have to follow that example. We have a formula there. Now, number 13 here, a poll found that 39% of male voters and 42% of females support a particular candidate. To test whether this candidate has an equal weight of support, right, between male and female. So we are trying to see the alternative hypothesis will be, everybody, based on this claim here, right? Do they have an equal level between female or male, right? So in other words here, the alternative H1 should be what? Should be, this one's not right. You cannot you cannot have an equal here, right? So H1 should be not equal because they did not say which one is higher, right? This one is even more confusing. How come you have a 2H1, right? Forget that. Number 14, many elementary school students in school district currently have ear infections, okay? Random sample of children in 2 different schools found that 16 out of 42. That's one school. 17 out of 30, another school. At alpha equal to 5%, is there sufficient evidence to support the claim that the difference exists between those 2 schools, right? And remember, everybody, this is for 2 samples for the proportion case, right? So you can calculate P1, you can calculate the P2, and using the formula from the section 9.4 to do the calculation, to calculate the test value. So at the end, you will see the test value will be close to one of them. straightforward calculation. Similarly, 30 out of 60 cats, 11 out of 40 dogs, right, slept more than 10 hours per day, right? They're trying to do their study, proportion case, similar to that first case. Go back to the lecture notes 9.4 to do the calculation. Number 16, a recent survey found that a sample of 300 students who attended 2 years colleges, right? 105 works at least 20 hours per week, right? Additionally, for just 4 years university, 20 out of 225, right? And what's the test value, right? To see the difference. So in this case, it's the same, the proportion, right? 20 out of 225, 105 divided by 300, that's the P2, right? Similar. Number 17, similarly, I'm not going to use that, repeat that again. And number 18, 64% of students live on campus. A random sample found that, okay, so 28 out of 45 male, right? 39 out of 50 female. So we are trying to see any difference between the male and the female, right? So the two proportion case. So using the same formula to do that, everybody. So that is for this 9.3, 9.4 homework.